All right, so counting methods. This is going to be kind of the end of probabilities, at least for this chapter. We are going to go into binomial probabilities in the next chapter, in chapter 6. So we're not completely done with probabilities, but like I said, what we're going to be seeing is going to be much different probabilities going forward. Because probabilities are going to still be a big part of this class. It's just that we're not going to be so worried about all these different kinds of calculations as much. But one of the things we need is different counting methods. So some of this is expected to be review, so I'm going to go over a few things kind of quickly here. So what we're going to look at is counting the different ways that something can happen. So I did this a little earlier in chapter, and this was at 5.3. I was telling you if we flipped a coin 5 times, that is, there's 2 opportunities for each coin, which means I had a total after 2 multiplied together 5 times, we had 32 different ways that we can flip 5 coins. So if an operation can be performed m ways, and a second operation could be done n ways, then the total number of ways to perform the sequence of 2 operations is m times n. So in general, if a sequence of several options are to be formed, the number of ways to perform the sequence is found by multiplying together the number of ways in which each operation occurs. So like I said, if I have 5 coins and I'm flipping them, the first coin, there's 2 options for it. There's 2 options for the second coin. There are 2 options for the third coin, 2 options for the fourth coin, and 2 options for the fifth coin. That means my total number of outcomes I'd get from all those coin flips would be, I did 32 different ways to flip 5 coins. Another example here is a certain make of an automobile is available in 3 colors, red, blue, and green, which isn't as important, and it comes in either a large or a small engine. So what we have here is there are 3 ways to get colors. There are 2 ways to have engines. That gives me a total of 6 ways that I can make this car. And how many ways can the buyer choose the car? There are 6 ways to choose the car. So another example of this would be license plates in certain states contain just 3 letters followed by 3 digits. And these are not, like your randomly made plates. How many different license plates can be made? Well, remember, a license plate is going to be a letter, a number, a number, a number. So I have 26 letters available for my first place on my license plate. The next one, there's another 26 ways that I can pick that letter. And there's another 26 ways I can pick that last letter. Now the numbers, we can have 0 through 9. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. Sorry, some people don't believe me that 0 to 9 does make 10. That is 10 different ways I can pick a number, 10 different ways I can pick a number, 10 different ways I can pick a number. If I multiply it all together, it's huge. 26 to the power 3 times 10 to the power 3. That is going to give me 17,576,000 different license plates. Which is why we're, like it used to be, but I think it was like only 4 numbers for a while for a license plate. And that's all we needed was just the 4 numbers. So that was like 10,000 options. But as more and more cars have been put out there and more people are living in a state and stuff like that, we need to expand that. So hopefully this is enough to cover every car in the state. And of course, we know some are going to be vanity plates. So this part changes it just slightly. How many different license plates can be made if no letters can repeat? So same setup, 3 letters, 3 numbers. So the number of how many numbers I can have, that doesn't change here. It's the letters that are affected. So I have 26 possible letters for my first letter. And because I cannot repeat a letter, once that letter is used, that means I only have 25 letters that I can pick for the second letter. Both of those letters are used, so then there's only 24 for my last letter. So sometimes there can be a little bit of restriction on how we do this. So this gives us different odds, and not different odds, a different number. So now we got 15,600,000 different license plates. Okay. As you can see, just a few like combinations here can just start turning into a big monster of different variety of plates that we can have. So when ordering a certain type of computer, there are 3 choices for the hard drive. So I have 3 choices for the hard drive. There are 4 choices for the amount of memory I can have. And there are 3 choices for the kind of monitor I can have. And how many ways can a computer be ordered? So I can have 3 different choices of hard drive, 4 different choices of memory, and then I can have 3 different monitors available to me. So this is going to be 36 different ways I can order us. So if I'm trying to order the computer from this certain place, I have 36 different ways that I can do it. A quiz consists of 3 true or false questions and 2 multiple choice questions with 5 choices. How many different sets of answers are there? So we got to think about this one a little differently. So I'm counting the different sets of answers. So I have 3 cases where I have true and false questions. So if they're true and false, that means there are 2 options. So if I have 3 true and false questions, I have 2 options for the next question, 2 options for the next question. If 2 of my questions are multiple choice with 5 choices, I have 5 options. I have 2 questions that actually have 5 different sets of answers to them. So how many different sets of answers do I have? Well, I have 2. Oops. 2 times 2 times 2 times 2 times 5 times 5. Sorry, my calculator kept sticking on something. That means there are 200 sets of answers. So what that tells me is that the chance of randomly guessing and getting 100%, that would mean I have to get all my questions correct. There's only one way to get all my questions correct out of 200. Sorry, probability of randomly guessing and getting 100% correct is 1 out of 200 or 0.005. That's part of the reason that you kind of design things the way you are. The chance that you get all those correct, not really high.